We want to look at this question related to independent events. For this, let's first recall some properties of independent events. So recall two events E and F are independent. If and only if the following equivalent conditions hold. So these are equivalent, they all imply one another. And by equivalent, I mean all conditions imply one another. So the conditions are that probability E given F is equal to probability of E, then probability F given E is probability of F. So conditional probabilities are equal to unconditional probabilities. They're independent. So conditioning on an event that you're independent to should not have any effect on its probability. Conditional prob equals unconditional probability. And then we know that probability E and F. So this comma means the under intersection is probability of E into probability of F. This means joint probability, or the probability of E and F, equals product of individual probability. So joint probability, the probability of the intersection, equals product of individual probabilities, right? So we know if two events are independent, then all these conditions hold. That the conditional probability equals unconditional probabilities, and the joint probability equals the product of the individual probabilities. Now let's apply it to this question. Now in this question, we want to find probability A union B, right? So now we know the probability of A union B using the inclusion-exclusion principle, or what we call the addition rule of probabilities, probability of A plus probability of B minus probability of A intersection B, right? So this is inclusion-exclusion principle or addition rule of probability, right? Inclusion-exclusion principle or addition rule of prob. Right now, since A and B are independent, we're given, right? It is known about the independent events. It's already given to us, right? Since A and B are independent, so this is given to us, right? It follows. Now, since they're independent, we can apply this, right? We know when two events are independent, the conditional probability equals unconditional probability, right? So we can apply this. It follows that probability of A given B, since A is independent of B, it's equal to probability of A, which is 0.4, right? And then it also follows that probability of B given A is equal to probability of B, which is 0.3. And finally, probability of A and B is equal to probability of A. It's just the product of the individual probabilities. And again, this only holds when they're independent. Otherwise, you have to apply the multiplicative rule, right? So 0.4 times 0.3 is 0.12. So this and this follow from the fact that they're independent. Since they're independent, the conditional probabilities equal unconditional probabilities, and the joint probability equals the product of the individual probabilities. So probability of A union B is just 0.4 plus 0.3 minus 0.12, right? Where this is probability of A, which is equal to probability of A given B. This is probability of B, which is equal to probability of B given A. And this is probability of A and B, which is equal to the product. And this follows from the fact that they are independent. So just equal to 0.5. So here we just applied the fact that A and B are independent. So their conditional probabilities are equal to the unconditional probabilities. And the joint probability is equal to the product of the individual probabilities.